lever, okay, this wheel and axle. It's all lifting up an object. It's changing its potential energy. And you will change the potential energy of this object precisely by the amount of work you do. Okay? And the amount of work you do is a force times the distance. It's a force times the distance. So in the case of this water, this wheel and axle for the water, you're going to apply a force through this circular motion. That force times that distance is the amount of work you're putting into the system, and that's going to change the potential energy of the load. Okay?
Remind me how you would measure the force. How would you say how much force that is? How would you measure the force?
I'm not sure how you mean practically speaking, how would you know?
Yes, what unit, how would you say, if you say it's force times distance?
Oh, you mean you're asking what kind of unit it would be in?
Yeah, how do you measure the force?
Force is in, it depends on, so I don't know what, so.
If it's force times distance.
Okay, you're asking about how force times distance actually can equal in energy?
I think so.
Okay. I'm sorry, I may be being confusing here. So force is in the units, in SI units is in newtons. You guys know that unit? Okay. And if you actually multiply newtons times the distance times meters, okay, so a newton meter is actually something called a joule. You heard that? So joule is actually equal to a newton meter. Okay. So a joule is a unit of energy. Newton is a unit of force. What? Unit of force times unit of distance.
Can you tell me how much force it's taking?
Is that what you're asking? Are you asking about a measurement? Like, how would I measure the force?
Wow.
It was like when I finally realized what you were asking, and then it was right in my hand. Yeah, you use a spring scale. Would that help you? Yeah. That seems like that maybe is not what you're asking.
I don't know, I just like, if I'm trying to find out how much work something takes, if it's force times distance, how do you say how much force this is, turning that to get that up? How much force is it? In distance?
Well, you would have.
No, it would be a force. You can measure it. So
you put the one end on the handle, and then hold the other and pull, and however long it takes, like that, will tell you how far it was, and that tells you how much force it was.
So it sounds like maybe you're thinking that we're having to mix these two units together, the force and the distance. But the force is the force. There's a force that we can measure with a spring that would be required to pull that weight up. So imagine the situation. So we can actually do it with pulley. We could actually see how much force. I could actually take this spring scale and pull on it and see how much force it takes to keep this steady. And that would tell me how much force. Are you with me?
Yeah.
Then you take that, and if you do like full rotation, you multiply it by the distance, and then however far the load moves,
That
how
one.
you would know. So if we made that center bigger, so more rope would wrap as you're winding, that would change your mechanical advantage.
Correct.
It would lessen it, yes?
What do you think? So here's the question. If I make this center larger, is my mechanical advantage now bigger or smaller? So is it going to help me or hurt me in terms of force?
Because for every one rotation.
This is actually one of your exercises. That's why.
Okay, I'll wait then.
No. We can talk about it a little bit here, but this is precisely one that you're going to make a water well, okay? And you're going to have two different axle sizes.
It's like a car with bigger tires versus smaller tires.
It is. That's right. It's the same idea. All right. Well, here's another. A little bit more. This is a little more subtle. What's this simple machine?
Wedge.
Oh, the food is here. Food's here?
Whenever you.
Okay. All right, I'll promise to let everybody go here in a second. Let's just do one last one. The wedge. Okay, so how does a wedge, what happens here with the wedge? The wedge is a little bit more complicated. It's not more complicated, it's just a little different than, it's kind of like the incline plane.
Push things apart.
So you have an effort force. I put load force over here, but your load force is really more of like a pulling apart force. Okay? So just the way that the forces balance, when you put a wedge into a piece of wood, what you're doing is you're essentially amplifying your effort force a little bit as you in other words, the forces pushing out actually are much higher than the force you're pushing down with.
I have a question, Mark.
Yeah.
I'm thinking, a knife is a wedge, actually. It can be a very sharp knife, Same size, everything identical except for the sharpness,
Right.
The sharp one will you need less effort to cut the
Correct.
same thing. So where...
So that's a little different. Let me see if I can explain that simply. When you have a so I'm going to introduce another simple concept, the concept of pressure. You all know that word, of course. But what is pressure? Pressure, does anybody know what that is in units in terms of force? Like, what's a...
Is it foot pounds?
It's a force per unit area is what a pressure is. It's a force per unit area. Okay? So if I have a dull knife, so if I apply a force to the table, that force is being distributed over some area with which I'm touching the surface, right? But if I have a knife, that same amount of force is being distributed over a very, very small area, which means that it's
smaller the area.
the sharper it is, the smaller the area. That means your pressure goes way up. So you have extremely high pressure with a knife because you're applying a small force, but it's over a very tiny area. And so it locally, right where you're applying the knife, it can do a lot of damage. Does that make sense?
So if the bottom of your wedge was rounded, it would require more force.
Yeah, I mean, what the wedge is doing is slightly different than what I just described.
Okay.
It's actually pushing out.
As it goes down.
It's got an amplified force pushing out relative to the force you're pushing down with. So you're getting mechanical advantage there. And I don't have a picture for the screw. The screw is kind of similar. So really these simple machines come in sort of different families. The wedge, the screw, and the inclined plane are kind of the same basic concept. The lever, pulley, and the wheel and axle are kind of the same thing going on in terms of mechanical advantage. All right, so what we're going to move on to, we're going to let you break for